Okay, guys. So, again, if number one's good for you, I just ask that you kind of like keep your voice down for a few minutes so that we can go through it and kind of get some people on the same page. And build hopefully some confidence up again. So, one of the things is making sure we're looking at the right pieces here. I think most of you guys had like the written down the period right and stuff like that, but just trying to make sure you're making sense of things. So this is like a 1/2 for our b. So then my period is pi divided by b. So pi divided by 1/2, so the period is 2 pi. Okay, the period is normally pi. Now it's 2 pi. So if the period has doubled, that makes the width of the graph double, but it also makes where the asymptotes are double. So, asymptotes in tangent are normally at pi over 2, 3 pi over 2 at all the halves, just because that's just the rule for tangent. They're always at the half values. But since our period doubled, we have to double this. If it was halved, we'd have to half that. Like it's whatever we do to the period has to be done to the asymptotes. So if I double pi over 2, it's just pi. If I double 3 pi over 2, it's just 3 pi. So these are where my new asymptotes are going to be. If you want to think about the negative, where do you think it would be? A negative pi. So they're like every other pi value. So tangent typically doesn't have an asymptote at 0. That's cotangent that has it. Okay? So if I know that's where my asymptotes are, getting those in the right spot is so important. So when I do this, I'm probably going to do pi over 2, I guess. So if I make this pi, so this would be 2 pi, 3 pi, here's 4 pi. So back here is negative pi. I don't know how you guys set yours up.
Pi over 3 is the same.
Okay. So asymptote here, and there.
No. Why did we have to go to the negative?
We didn't have to go to the negative. We could if we want. Yes. What?
I just want to know.
I don't have the answers in front of me.
I know.
Yeah.
Wait, hold on. She asked.
What the what? Yeah, the third of the way, so 6. Yeah, that sounds right. I just working quickly. Yeah. Okay. So guys, now tangent normally starts at 0. It's still going to start at 0. Even if you multiply 0 by 2, it's still just 0. So tangent still starts at 0 normally. However, we need to shift it down 1, right? Is it down 1? It's up 1. Up 1, sorry. Up 1. Oh, this is tangent, sorry. There's so many of those were cotangent that I...
They just blend in and confuse us. I am going to need
It goes. So for cotangent, the first one is here.
All right.
So the period is where the next line is.
Yeah.
I never actually thought of that. Minutes. The period is where you're. I literally just do it on a tangent. So the period is what is half divided by? What is 0.5 divided by 3? I actually didn't know that.
We would multiply pi over 2.
So this guy, that's the
So this one is not right. This is sign
this is
of.
the V, this is the X. And then this is what
So
makes
yes,
it.
it's
And
the
then
one
right,
with
and
the
then if there's
period.
something else here, then
So
you
this one, then you do the double sign.
My sister's asking me how to
It's the victory sign.
but it also depends on how you use
I got, wait, sign two. Sign two.
Can I go fill her separate, please? Alright, you guys suffered enough? Are you guys ready to go through some together?
I would appreciate it to check my problem.
My lens. Don't hold one.
I did Kyle.
I'm tied all over and my mom will not do anything for me. It sucks. And I try to pay my brothers, but they're always like, no, what am I going to return? I'm like, you get paid. It sucks. I'm like so loose right now. It's a good thing you just asked me to go on too.
I think it's a little too late for me to just kind of think my parents
Yeah. That's your zero.
That's doesn't matter about that tangent.
That's only my shirt.
That's the beach.
Okay, yeah, all he does is get your game until you. All
Well,
of
see,
your
James has stuff to ask.
you get his game.
Oh, every half. Yeah, but then they're gonna get from like a third of that.
You get their game.
So that's what I'm gonna go through for. Okay, guys, I'm gonna start talking about these. So again, if you're good on them, I just ask you guys kind of keep voices down. I'll run through these and make sure, hopefully everyone's getting closer to being on the same page with these. For our homework, half of our homework is doing more tangent and cotangent practice, because I think we need that. So, all right. When we're talking about cotangent, this is my A value. This case, B is just 1. So our period is pi. So guys, especially if this didn't go well, please be doing this with us, or if you didn't know what to do. So the period is just pi. Now, cotangent normally has asymptotes at the whole values. So there's normally asymptotes at 0, pi, 2 pi, like the normal ones here. The period's the same, so that doesn't change. However, these get moved over because of this. This is going to go left, pi over 2. Or pi over 4, sorry. Just to confuse you, yeah. Since they're using pi over 4, that's what I would use as my scale. So pi over 4, pi over 2, so this is going to be pi, 2 pi. So every space is a 4. So there's normally an asymptote at 0. I need to move left 1 space. There's normally an asymptote at pi. I need to move left 1 space. Normally here, move left 1 space. Again, those of you guys who said you were done before, I really suggest making sure that yours look like ours and that you're not like falsely correct. I'm not saying that anyone's wrong. I'm just trying to make sure that you check as you're going here. Now, we need to figure out where these cross. So this is cotangent, so it should be going downhill. It doesn't shift up or up at all. So I just need to find the middle of this, and that's where it's going to go through. Now, technically, the 3 would make this like a little more stretched out, but again, don't worry about that part of it. Okay. Cat's crying. All right. All right, so let's move on to 3 if we could. Whoops. All right. Now, this one's kind of a strange one, number 3, because our shift kind of makes it look the same. So that, like, if you like, kind of like this seems strange, it's because it is a strange one. So cotangent, again, the B value is 1, so the period is pi. Now, typically, there's asymptotes at 0, pi, 2 pi, 3 pi, all the whole values. However, we're shifting it over pi. If I move the asymptote over pi and the asymptote's at pi, it's in the same spot. So this one actually is kind of like a deceptively easy one, or easier. I don't want to call it easy. So there should still be one at 0. I don't know what your spacing did. I did halves, so I made this pi, 2 pi. It doesn't really matter as long as, again, you're consistent. Make sure when you guys do a scale, if I have you guys do that, that you make your scale very clear to me, because that's probably the best way for me to check that what you're doing. Now, the only thing we have to remember is the cotangent moves down 2, so normally it crosses at 0, so it moves down 2 to cross at -2 there. So it should cross at -2. Is that all you forgot to do is shift it down? Well, you have to check your scale. Yours might be right if you had the right scale. So if the period is pi, then just make that, this is 0 and that's pi then.
Yeah.
It's fine. It's your scale is just different than mine.
Okay.
You counted by, fourths or whatever, and I counted by halves. Yeah, don't let your scale throw you off. Like, if you did a different scale, I'm looking for those major points. So some of you guys were asking me to check your work, and I was basically looking for like kind of some milestones, like where did it cross 0, where is the asymptote? Now again, this is our a value. This just means it's a really curvy tangent function. The b value is 3. This one's definitely a tougher one. So the period is pi over 3. So the period is a third of what it typically is. Now that means that we have to change the asymptotes. Typically the asymptotes for tangent are at the halves. And this does require you guys being okay with some fractions. And I know that's not everybody's favorite thing. So what I have to do is I'm not doing the pi, I'm just multiplying these all by a third. So I have to take a third of them as well. So a third of pi over 2 is pi over 6. That's going to be my first asymptote. A third of 3 pi over 2 is going to be pi over 2 because those 3's will cancel. My next one is going to be 5 pi over 6. So if I have about 3 of them, I'm probably pretty good to go. Now I'm going to use 6 for my graph. And again, it just requires you guys to be comfortable with some fractions. Now the first is a 6. Then it goes 2 6, which is technically a third, if you want to write it that way. If you want to call it 2 6, I don't really care. Then it's 3 6, then that's really a half. 4 6 is really 2/3. 5 6 is just 5 6. And then 6 6 would be pi. Yep.
If you did your scale by thirds, but you technically like still put the middle.
Yeah, the middle of it, that would work. Yep. Yep. So if you heard her, she said she used thirds for her scale instead, and then she put the line between because it was a 6. That works. It's fine if that works for you. Okay? So we have an asymptote at pi over 6. We have one at a half pi and one at 5 6. Once I kind of know the pattern, I could keep going with this. It's basically every other based off of my graph. It depends on your graph though, like how you guys set up your scale. Now this one is tangent, so it should be going uphill, going through 0, and again, really curvy if you can, but not a big deal. Right? And again, I did this not to like, hey, like you hate these things, so let's do 4 more of them. It's not what I was intending here. I was really just trying to expose you to more. The more practice you guys get with these, the better you will get. And I promise I will try to keep like test questions to be more on the side where I feel like they're fair questions, not these crazy like, I would say this was a tough, like this is a tough one. Like I think when it becomes like we're dealing with 6, I think that's probably a little bit more difficult, but I think some of the other ones, once you get the concept down, it really, doesn't require a ton of prior knowledge that fraction work. All right. Okay. I'm gonna bribe you with some candy. I'll give you some candy treat.